Hello guys, in this video we're going to continue our discussion about the second order Bode plots, or basically quadratic balls with zeros, which are basically these simple standard forms. Okay, so last lecture we gave an introduction about these standard forms, how to draw it. Okay, and we mentioned that the standard form of a quadratic ball or zero, okay, or second order Bode plot basically will be something like that. Okay, so whenever you have like a function h of omega that resembles or like similar to these two standard forms, you have to convert it somehow into one of these, either quadratic zero form or the quadratic ball form. Okay. Okay, so let's look at that example here. We're gonna take two examples in that video or that lecture. That's the first one. So we have here 300 in the numerator, and the denominator is 300 minus 3 omega square plus j 90 omega. Okay. First of all, there should be like one. A term with one. Here you have a constant term. It was 300. Okay, so let's take 300 as a common factor. So we can write h of omega in that way. We have 300 in the numerator, so we're going to have a 300 as a common factor here. So 1 minus 3 over 300 omega square plus j 90 over 300 omega. 300 will go with the 300, so h of omega will be 1 over 1 minus 3 over 300 is 1 over 100, or omega square over 100, plus j 90 over 300. 0 will go with the 0, divided by 3, so this will be 10. So j 3 omega over 10. Okay, still we need to like have another trick so that it will be like that. Okay, we have the 1, that's good. We have this term, that's also good. Okay, but we don't have this one. So look at this. This is omega square over 100. Okay, there is no j. If you want to introduce j, but there is minus 1. You know that minus j square equal to minus 1 because it's equal. J is the square root of minus 1. So square root of minus 1 multiplied by the square root of minus 1 will give you minus 1. So this can be written as 1 over 1 plus j square omega square, and the 100 can be like 10 multiplied by 10 or 10 square, right? Plus 3, I'm sorry, j 3 omega over 10. Oh yeah, we got it. So that would be 1 over 1 plus j 3 omega over 10 plus j omega over 10, and everything to the x1 out of 2 or squared. Okay, now let's compare. Let's compare with 1 plus j 2 zeta, okay, omega over omega c plus j omega over omega c to the power of 2. So if we compare, 1 is like 1. This term means that omega c equal to 10. Also that term can conclude the same, and they have to be the same, of course. And how about Mr. or Mrs. Zeta here? So for zeta, looks like 2 from that term as well. 2 zeta is equal to 3. And from that, zeta is equal to 1.5. And it's higher than 1 over square root of 2. We take last lecture that zeta, will change a little bit the graph, the plot, the Bode plot, based on its value. There will be some smoothing, okay, or some peak resonance or resonance peaks. So in that case here, and this under some condition. So we have to determine zeta and compare it to 1 over square root of 2. If it's less, that will result in some resonant peaks. If it's higher, that will be just a smoothing to the curve. And in our course, the book doesn't care about that. So the book says, yes, there will be some smoothing or like peaks, but we just draw like the crude plot, Bode plot, without these peaks or smooth. Okay. Okay, so that's good enough now. So now we have to do, now we can start drawing the Bode plot. Okay, so again, we draw 20 log the magnitude of h of omega. So 20 log magnitude of h of omega means 20 log the magnitude. I'm gonna like flip the numerator and take everything to the power of -1. So 1 plus j3 omega over 10 plus j omega over 10 square, everything to the power of -1. That's equal to -20 log. So that's the magnitude. Magnitude of 1 plus j3 omega over 10 plus j omega over 10 square, everything. That's what. We said that there are two cases for that function. Number one, when omega over omega c tended to be 0, very small, okay? And in that case, we're gonna neglect every term that has omega over omega c or omega over 10, because omega c is equal to 10. Here it is. So in that case, 20 log magnitude of h of omega will be minus 20 log magnitude of 1, which is 1. And log 1 is 0. So in that case, whenever omega over omega c or omega much less than omega c, that will be 0. Second case, omega over omega c tended to be infinity or very high. Okay. Let's do that in detail so you can understand very well. 20 log magnitude of h of omega. Okay. What is the magnitude of h of omega? Okay. So this is h of omega. And the magnitude is the square root of the real square plus the imaginary square. What is the real square here? Or what is the real part here? The real part is actually the 1 and this one here, j omega over 10, everything is squared. Why? Let's go back to the origin like of this like term. It was actually minus omega square over minus 100. That's basically real 100%. But we just manipulated it by taking the -1 and make it j square, but doesn't change the nature of it. It's real because j square is -1. It's real number. Okay, not imaginary. So this is 1 plus j omega over 10. Well, then we're gonna square everything again. Okay. Because of the magnitude. And the imaginary part, of course, it is j 3 omega over 10. So the imaginary term here is 3 omega over 10. When omega over omega c tended to be infinity, okay, of course we're gonna neglect the 1. So the 1 will be neglected because 1 will be much less than omega over 10 here. In that case. And also we have another observation. So let's do that with another color. So black, for example, this one here is omega square over 10 square, omega c square. Okay, this one here is omega square over 10 square, and everything is square again. So that's actually omega over to the power of 4 over 10 to the power of 4. And when omega over omega c is much tended to be infinity, of course, that guy here will be much higher than that guy. So omega to the power of 4 will be divided by 10 to the power of 4 will be much higher than omega to the power of 2 over 10 to the power of 2. So that's also will be neglected. So like this with our original color. So that's the first result of that. The second result is that the 3 omega over 10 square will be neglected as well. So that means that the 20 log h of omega will be approximately equal to, I'm sorry, here is 20 log square root, and you have only the j omega over 10 square, and there is another square from the magnitude definition. So that's equal to 20 log, I'm sorry, this is minus 20 minus the type. Yeah, minus, you see that's minus. Minus 1, we bring it down, so it's 1. And basically, let's see what's under the square here. You have minus 1, okay, omega square over 10 square, and everything squared again. So that's equal to minus 20 log square root of power 4 over 10 to the power 4 log omega square over 10 to the power of 2. Again, that's equal to minus 20, I'm sorry, minus 40 log omega over 10, omega c, okay? Now let's take like some examples for that. When omega equal to omega c remember is 10, okay? That will give us minus 40. Omega equal to 10 omega c, which is 100, that will give us minus 80. Omega equal to 100 omega c, that will give us minus 120 decibels, and so on. Okay, now we can draw now. We can draw the curve now. Okay. Minus 20, minus 40, minus 60, minus 80, minus 90. Oh, 20, 40, 60, that's then 100 minus 120. We have 20, 40, 60. Of course, I made the negative more than the positive because everything we have is negative. Minus 40, minus 80, minus 20. Here is omega. Make it multiples of omega c's. Omega c, remember, is 10, right? So you can have tens of that, like, for example, 1 here, 10, 100, 1,000, 10,000, 100,000, and so on. Okay, let's now draw this, for example, red. Okay, when omega is much less than omega c is 10, we have 0. So this is omega c here, everything is 0. Then when omega is much greater, omega over omega c tend to be infinity. Starting by omega c, when omega c is equal to 10, we have minus when omega c, I'm sorry, yeah, I made a mistake here. So, okay, when omega equal to omega c, log 1 is 0, so that's 0. That's 0. When omega equal to 10 omega c, that will give us log 10. Log 10 is 1, that's minus 40. 100 minus 80. Omega equal to 1,000 omega c, that will give us minus 120. Sorry for that. Let's go back to it again. Okay, so at omega we have 0. At 100 we have minus 40. 1000 we have minus 80. Sorry, this is, yeah, this is 100 omega c, 1000 omega c, 10,000 omega c. 10,000 we have one. Then we can connect these together. Okay, that's basically h of omega is a Bode plot of that quadratic function. Okay, or second order h of omega. One last thing for our course, that's it. Now, if you like, if you if the viewer of this video doesn't belong to our course, you have to like manage or have some smoothing or add peak resonance that get based on the value of z. Let's do that. So the value of zeta, okay, we have zeta equal to 1.5. 1.5 is higher than 1 divided by the square root, because this guy is equal to around 0.7, 0.707. 1.5 is almost his level of that. Okay. Based on that, you have to do some smoothing. I'm going to show you how to do that. So let's do this with green, for example. So we start with 1 decade before omega c. Here is omega c. We start from here. Okay. And we're going to end 1 decade after omega c. So we end. What we're going to do? We're going to do something like that. So you start smooth it, like going down with a curvature. You meet again with the curve or the straight line at 1 decade after the omega c. It continues there. So before that, it's all before 1, everything is red here. After the 1, it is the green curve. After 100, it is basically the red again. But for our course, it doesn't, you don't have to do that. Okay, guys, that was the first example on, the second order Bode plots. This is like 10 minutes or so, 15 minutes maybe. So in the second video, I'm gonna do, and next video, I'm gonna do another example, much more or more complicated than this one. Okay, but it's gonna like make like the idea, easier to understand. Thank you very much for watching, and see you. Bye bye.